wishing that I had instead used discrete transistors. So on this one, I got rid of the LM386 amplifier. I dug around on the internet a little bit. I found that there were other BitX builders who had similar feelings, and these guys had come up with discrete component audio amplifiers for the final stage. So you'll see no chips in mine, so it's chip-free.
Still hardware defined.
I'm sorry?
Still hardware defined.
It's still completely hardware defined. And then, again, this is just my preference. Again, there's a million different ways to build a radio. I prefer analog and discrete because, like, for me, it keeps the rig completely understandable. There's no mystery ICs in there that you don't really know how they're working. There's no lines of code controlling it. You make all of the signal, or you make more of the signal. And this is my view. And also the simplicity of the thing is a real virtue. So again, this is just a matter of preference. And I'm going to, when I get to the end, you're going to see I'm going to deviate from these principles probably in my next project. But so there's no reason to be dogmatic about it. But when I built this one, these were the kind of ideas that I had in mind. The construction technique that I used on this is called Manhattan construction. And you can see it, later on you'll see it, but I'll just kind of hold it up. But there's one big PC board, and there's no etching. And what you do is you glue to the top of the board with super glue little squares or rectangles, circles if you like, whatever you like. You glue them on there. When you have to make a circuit connection, two components, you solder them onto the top of the isolation pad. Anything that needs to go to ground goes directly to the copper-clad board underneath. They call it Manhattan because it looks like Manhattan. If you look at the board from the side, all the components are rising up, sort of like the skyline of Manhattan Island. Other people say it's Manhattan because if you look at it from above, the squares and rectangles look like the street grid pattern of Manhattan Island. So either way, I like it. I was born there, so I guess that it creates a certain affinity with Manhattan. There's no etching. My fingers are not green from that horrible chemical that you get from Radio Shack. It all goes together very, very fast. You can look at that schematic, and then just when you start getting good at it, you start getting these little pads, and you glue them down, and then you put the circuit down, and it's almost like a direct transfer from the schematic to the board. You're doing more than board stuffing here. Now, again, I don't want to offend anybody. I don't want to put other ways of approaching this down, but there are boards available for this. You can go out and buy a PC board and build it that way, and many guys do. And on future projects, I may do that. But again, I wanted to sort of keep in the Gene Shepard ethos here. So this is more than just stuffing a board full of components. This is actually making the board yourself, but without going to all the trouble of etching. It creates an excellent ground plane, and one of the real advantages is it's easy to modify and repair because it's all on one side. It's all above board. I mean, you guys have worked on these boards where you have to pull it out, flip it over, and you break the leads, and you melt the leads off the board. This is much, much easier. It's kind of ugly, and it works. Right? Everybody really likes it. And actually, it's kind of a derivation of what Wes Hayward calls ugly construction, or dead bug construction, where you actually solder stuff or glue the components to the board and have them with their leads up, dead bug style. I like Manhattan a little bit better, so I went with that style. And you can take a look at it later on. I have the rig up here. Now, one thing I did when I built this thing, I didn't know I was going to come here to talk, but I thought it would be fun to take pictures of the board as it progressed. So that's what I've done. And there it starts, one blank slate, 8.5 by 11, given to me by a friend, Jim, W8NSA. It's like an artist facing a blank canvas. There's Farhan's schematic, and I did a little plan, a little rough plan of where I was going to put the stages. Planning is good. I'm trying to do more of it. I joke on the podcast that the correct sequence is design, plan, build. I've been guilty of getting that reversed, and I'm trying to reform here a little bit. So there was some planning, and there it is. And this is my layout. This is sort of after the whole thing was built. I stuck generally with the plan I had, but when it was all over, I wanted to describe to other people who were building BitXs how I did my board. And so this is the 8.5 by 11 board, and these are where the various stages are placed. I think it's important to realize that it's not just a mass collection of parts. This is a collection of stages, and that's the way I built it. That's the board layout. And you can see the bidirectional amps. that I described before. Here's the first one, here's the crystal filter, second bidirectional lamp, third bidirectional lamp, and really the rig is built kind of feeding into and out of these three stages. Okay, now we'll go through it. Here's a, I didn't stop at every stage, but here's like the first round. First I built the VXO, and there it is, and it's actually on a separate little board. And then in the lower corner, that's the microphone amp, and then the carrier oscillator. The idea is you build these stages, the best thing to do is build one, stop, test it, make sure it's working. Apply power, put signals in, take a look, and then move on. And that's really strongly recommended in this approach. Here we add the balanced modulator stages and the first bidirectional amp. This is kind of interesting up here on the upper side there. That's what the first bidirectional amp looks like. You can see I used kind of a Sharpie to kind of square out the territory that each stage was going to operate. And I kind of kept them within those boxes. And again, you can see that what's coming together here is not just a mass of parts that are being thrown down on the board, but it's being developed stage by stage. There's the second bidirectional amp. You can see it looks almost identical right there, and the board is starting to fill up.
Is the Sharpie line a cut line?
No, they're not. I just mark it there. I just draw it. I'm not cutting anything.
It's a matter of discipline rather than...
Right, it's just a matter of organizational, yeah, discipline, yeah. Nothing is cut. The copper clad board was never cut at any point. It stayed completely uncut. There's a diode ring mixer that mixes the VFO signal with the incoming or outgoing RF. There's the third bidirectional amp, and you can see down here I start building the audio amp, the discrete audio amp that I told you guys about.
Is the position of those on there controlled or indicated by proximity requirements? Right?
What you really have to do is you just have to make sure that the gazintas are far from the gazoutas, that the inputs are far from the outputs. And you have to, as you're doing it, as you do that initial plan, where you've got to think about where your higher powered RF is going to be, and you want to kind of minimize the feedback path to the input of amplifiers that could cause oscillation. So I didn't have to do a whole lot of planning, but some. And the idea is basically to try to anticipate, which stages are going to have to go to each one, and what's the best way to avoid feedback and oscillation that's going to cause you heartache later on. But there's the AF amp down there in the lower corner, and as you'll probably see that I went through some experimentation and changes before I got it the way I wanted. Now, filters, the pre-driver, and the wiring. So now I built two filters, and really the heart of any SSB rig is the crystal filter. Here's the crystal filter up here. These are the 5 megahertz crystals that I described earlier. And there's a bandpass filter down here. Now, and the wiring is kind of interesting. I just color-coded it. Red for receive, green for transmit, and then black for stages that have to stay on in both receive and transmit. And this was very helpful because as I was troubleshooting and trying to figure out what was going on, it was very easy to realize that the red line was powering the receive portion of the transmitter. When you read the article that Farhan wrote, it was kind of cool because he points out that at this point, the receiver works. He says, so he recommends, take a break, pause, turn that receiver on, and listen to the magic that comes from a receiver that you built yourself. And I did that. You'll see the RF stages aren't even built yet. A good portion of the transmitter is not ready. But the receiver is, and that was really neat because you turn it on, and wow, you're listening to this thing. It sounds terrific. It really sounds great. And so I did take the break that Farhan recommended, and then we went on. Oh, I used, for the interstage coupling, a lot of guys use RG174, that little thin coax. Get away from it, because that gives you what's known as Murphy's whiskers. The braid on that coax, inevitably, pieces of it break off. And you'll have little bits, little tiny wires floating around in here. And oh man, it causes a lot of heartache. This stuff, this silver coax that you see here, it's Belden 1671A. It's got a Teflon dielectric. And there's no insulation on the outside, on the shield. So you just solder the shield right to the board wherever you want. The Teflon never melts. There's no Murphy's whiskers. I really recommend it. You can get it on the web. It's great stuff, and I'd stay away from RG174. But we fired it up, the receiver works, it was great fun. Now here I just added a TR relay. You don't even really need a TR relay. Farhan's rig has just a switch, and in the up position, the receive line is powered, in the down position, the transmit line is powered, or vice versa. But I wanted to use push to talk because I have an aesthetic D104 that I'm very fond of. So I put a TR relay in there. The push to talk on the D104 controls that little relay. Don't forget to put a diode in the cap. I always tell you that because those relays, the coil in there will put a really huge electromagnetic pulse by your circuitry. A little diode cap across it. It's an old trick and it really saves a lot of trouble. Here's the driver and the power amplifier. Actually, I was starting to run out of room here. You look at that board at the beginning, you think, oh, I got plenty of room. And then you always wish you had a little bit more. But here's the driver, the final, and the low pass filter. You can see the heat sink there, right there. That's the IRF 510, that's the final. And it gave me a little trouble, but not as much as I'm really used to. So this thing then is built. It's not even in the box. It's sitting on the bench just like that. That's what it looks like. I threw a Heathkit knob on the front. The variable cap is actually out of a Heathkit QF1 Q multiplier. It's a nice little capacitor for this thing. And it's sitting there on the bench. And I'm checking the receiver, check the transmitter with a dummy load. It's looking good. So I fired it up. And the very first contact was with a CU7 station in the Azores. And let me tell you, that is a sweet moment. When you built this thing, it's sitting there, it's not even in the box. It's as far away from kind of an appliance rig as you could possibly get. It's just a bunch of electronics on your workbench. There's still little bits of solder and wire floating around. And I've got this guy in the Azores, where I used to live, telling me that he's hearing me 5.9 and it sounds good.
And you didn't have the antenna attached.
A dipole. I did have the antenna. I did have the antenna, yeah, but it was really good. I've only used a dipole antenna with this thing, so that was a good moment. And I really think that we should come up with a name for these contacts, these initial contacts, because for me they're the most memorable and they're some of the kind of the nicest experiences in home brewing. Then I put it in a box. People said, "Oh, you got to put it in a box." So I thought about what kind of box I was going to use. I actually went down to Michael's to buy some little boards. But then I realized that they had available this kind of cigar box thing that fit perfectly. The board fit perfectly, so it was almost fate that I put this in the Michael's box. There's no shielding, it's wood, and a lot of people said, oh, you need metal shielding around it. I don't notice much of a difference. I'll show you, I built a second rig, and I coated the inside with copper flashing that you can get at Home Depot, but I don't notice a lot of difference, so it seems to work pretty well either way.
And you get the wood with cigar cherry smells or
No, no cigars. No actual cigars were harmed in this project. There it is, and it's got only 3 controls. There's the AF gain control there on the left. The second switches to 2 crystals. I have 2 crystals in there. This gives me coverage of about 40 kilohertz of the 17-meter band, which is most of the phone band on 17 meters. I could put a third one in there, but I really don't need it. And the switch on the front panel just controls another little relay that takes 1 crystal out of the circuit, puts the other one in. So I have like essentially 2 little sub bands within the 17-meter band. It's extremely stable, it's really nice. And it's a little bit different than running a regular rig, but you just throw the switch over. A guy asked me the other day, he said, what frequency are we on? And I said to him, buddy, I know we're on 17 meters, that's about it. Now, I could calibrate it. I could come in there and come up with a little calibration dial, and I will eventually do that. But for now, I mean, I know that in one position I'm sort of towards the top of 17 meters. I know in the other position I'm a little bit further down in the band, but it doesn't make much difference to me, and I've been using it this way for a while. I guess I could put a frequency readout in there. Somebody suggested that I put Hindi language markings on it because of its Indian origins, and I briefly thought about that, but all the guys in India mark theirs in English, so it would be kind of silly. There's no glowing numerals and no S meter, but there you have it. How long did it take? This is a question I always get, and I actually had to check. I started work on it on August 20th. I work a little bit each morning before work.